Lastly, let's look through some systems where you can use whatever method you'd like. I think when given the choice, I like to use elimination myself, but to each their own. I'd also like to show you how to use use elimination if you can't just add the equations immediately together. Like for instance, 8 plus -2 is 6, 3 plus 1 is 4, and just multiplying by negative doesn't really fix the problem like we saw a couple of the previous examples. However, that same idea though, by multiplying through an equation by a single value, and if you choose to alter the numbers but keep the solutions the same, can be useful in cases like this. Like for example, although I can't add these two equations together, if I could somehow change this -2 into a -8, 8 plus -8 would be 0. So what can I do? Well, I can do that by just multiplying the bottom equation by something, whatever times -2 is -8. In that case, it's 4. So I think I could use elimination if I just multiply everything in this bottom equation by 4. And I get something like this. The top equation is the same. The bottom equation now is 4 times -2 is -8. 4 times y is 4y. And 4 times 4 is 16. Now when I add these equations together, I get no x's. 3 plus 4 is 7 y's. 12 plus 16 is 28. And well, I get y by itself pretty efficiently. Divided by 7. Y is 4. Once I know y, I can find x. I'm going to plug y back into the equation that's easiest for me to solve. In this case, I actually think it's the bottom equation because the numbers are smaller and y is pretty much already by itself. -2 times 4 plus y equals 4. -8 plus y equals 4. Add 8 to both sides. Oops, that's what I get for going too fast. I plugged in 4 for x. That's not ideal. How about -2x plus 4 equals 4. -2x equals 0. 0 divided by anything is 0. So I think the point x equals 0, y equals 4. Similar situation for the remaining two. I could, looks like to me, in this equation, I could, maybe 2 and 4 are pretty similar numbers. If I doubled 2, I'd get 4, and 4 plus -4 is 0. So I'm going to multiply the top by 2, and then add together and solve. So, multiply by 2, I get -6x, I get 4y, and I get 14. The bottom equation has not changed. I add together. -6 plus 5 is -1. 4 plus -4 is 0. 14 plus -15 is -1. So if -1x equals -1, x equals +1. If I know x, I can find y. Maybe I'll use the top equation because y is positive. -3 times 1 plus 2y equals 7. -3 plus 2y equals 7. Add 3. 2y equals 10. Y is 5. I'll leave the last one for you to solve. Again, check the answer key to this worksheet on Canvas to check your answer for this last one. This final story problem, Recreation Center charges non-members $3 to use the pool and $5 to play basketball. And if this non-member pays $42 and they use the facilities 12 times, how many times did they use each? In particular, how many times did they use the pool? I think this is a lot like the fish example from a couple of videos ago. Only thing instead of kinds of fish, this is like types of use. So I think what I know is like the number, I know the money that's been spent and the number of uses are the things I can relate. because I know that the total money spent is $42. I know the total times used is 12. To that end, if I maybe say P is the pool usage, then I know that it costs me $3 every time I use the pool, and it costs me $5 every time I use the basketball courts. So 3 times P, 5 times B, add them together, and that's the money I spent. That's $42. Similarly, if P is the number of times I use the pool and B is the number of times I use the basketball courts, then if I add those together, I should know how many uses I've done. The number of times I use the pool added with the number of times I use the basketball courts, that's how many times I used everything. P plus B has got to be 12. So you could solve this system of equations in any way you see fit. I'd maybe use elimination, maybe multiplying to eliminate either the P's, or maybe even more to the point, I'll try to eliminate the basketball uses because I want to know the answer to the pool. So maybe a straightforward way to solve this, or the most efficient way to solve this, might be to take my second equation here and multiply by minus 5 to turn this 1b into minus 5b's. And then these b's will add to 0. And when I solve for p, I'll know the pool uses. Try this on your own and check your answer on Canvas.